All right, everyone. So let's take a look at question 1. So it says, a painter will paint n walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression n times k times L times h, where n is the number of walls, k is the constant with units of dollars per square foot, L is the length of each wall in feet, and h is the height of each wall in feet. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change? Well, so if we look at this expression, right, we're wondering, okay, which of these factors will change? Right, so L is the length of the wall in feet, k is a constant. If we look at k, for example, right, in this case, k is a constant, and it relates the units of dollars per square foot, right? We have all of these other factors changing. The number of walls, the length of the walls, the height of the walls, but length, height, and number, right, they all depend on how expensive k is, right? So therefore, depending on k, which represents sort of the cost of dollars per square foot, right? If k is larger, then the cost goes up. And if k is smaller, the cost goes down. So therefore, k is the factor controlling is the factor that would change should the cost go up, right? Okay, 2, we have a simple equation here. It says if 3r equals 18, then what is the value of 6r plus 3? Well, 3r is equal to 18. Then we can simply divide by 3. We'll get r is equal to 6. And then since we know r is equal to 6, we'll have 6 times 6. We'll just plug r into this equation here. Plus 3, which is 39, which is D. Now we want to know which of the following is equal to a to the 2 over 3 for all values of a. Well, we know an exponential law that states a to the k over n is equal to a to the k to the nth root, which basically means that any expression worth a fractional exponent can be written as the nth root of a to the k, where the exponential power is k over n. And so in this general format here, a to the 2 over 3 is equal to a squared, and we'll take that as the third root. So by this logic, our answer here is D. Remember, these formulas are good to remember. If you need a review, I have another video on my channel that explains them. Question 4. The number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined the United States between this time period, right? So we know 30. We'll call this one time period 1. And X states joined between 1850 and 1900. X between time period 2. And which of the following is true? Well, we know there's 30 here, and we know that this is double X. So we know that, well, since it's double X, we know that X is 15. And based on this, we know that 2 times X is equal to 30. So none of these other relations make logical sense in the context of the problem. That means that B is the only good answer here, because the rest of these, they don't make any sense. We want to find the value of X over 5. Okay. The first thing we have to do is isolate X by cross multiplying. 15X equals 5X plus 100. This is just a distribution of 5 times X plus 20. Right, from there we can solve for X. 10X equals 100. X is equal to 10. Therefore, X is equal to 10, so 10 divided by 5 is 2. C is the correct answer. Okay. If X comma Y is a solution to the systems of equations above, we want to find the value of X minus 1. Okay. Let's see here. So basically, in order to find the value of X minus Y, we have to solve this system of equations, right? And so we're going to do that using a technique called substitution, which you may be familiar with. So the first thing I'm going to do is isolate y on its own, right? So we'll get 2y is equal to 3x plus 6. We divide both sides by 2. We get y is equal to 3/2 x plus 3, and then using this value of y, we'll plug it back into this equation to solve for x. We will get 2x minus 9 halves x minus 9 equals negative 14, plus 9 to both sides, plus 9, negative 5 equals, this is 4 halves x, negative 5 halves x. So those divided by 2 times 2, negative 5x equals negative 10. It means x is equal to 2. And since we know x is equal to 2, we can plug the x back into either one of these equations. I'll do it over here to find our value. So we get 4x minus 3y equals negative 14. Sorry, that's 4. That means negative 3y equals negative 18. Means y is equal to 6. So therefore, we can find x minus y as 2 minus 6, which is negative 4. And that, of course, is C. Again, this is a simple system of equations problem. 7 says, a function f is defined by a polynomial. Some values of x and f of x are shown in the table above. And they want to know, okay, which of the following must be a factor of f of x? Right. So we know that basically f of 0 is equal to 3. So in this case, right, well, we know that looking at this, we know that for this polynomial, right, this polynomial here, this x to the n, right, plus x to the n minus 1, this term that looks like x squared plus 5x plus 6, something like this, right? When we plug in 0, right, we will actually get 3. We also know that f of 4 is equal to 0, which means that when we plug in 4, we get 0. This piece of information is more useful to us. This gives us sort of the intercept. This tells us, okay, a key piece of information. That basically means that this polynomial has to contain the term x minus 4, right? And the reason for this is, well, when we plug in 4 to this portion of the polynomial, this will evaluate to 0. And so we'll end up getting this part times some other random chunk, right? This is random. And therefore, x minus 4 must be a factor of the polynomial because there must be some portion of the polynomial that contains the part x minus 4 because f of 4 is 0, which means that when 4 is plugged in, you'll evaluate the polynomial to 0, right? Two things being multiplied like 2 and 4, these would be called factors. The same is true of a polynomial part like x minus 6 and x minus 2. These are both factors. This is a refresher there. Okay, question 8 says the line y equals kx, line y equals kx plus 4, where k is a constant, is graphed in the xy plane. The line contains some point CD where neither value is 0, right? They want to know, okay, what is the slope in terms of C and D? Well, we're given a line. And as you know, this number here, this signifies the y-intercept, which means that when x is equal to 0, y is equal to 4, right? So that's what this tells us. Or if it was negative 4, this would be negative, right? So we have also the point C, comma D. So we know that these 2 points both lie on the line, right? Because if it's a y-intercept, it still lies on the line, right? So then we can apply the slope formula. So m, which refers to the slope, is equal to y2 minus y1 over x2 minus x1. You can label each one of these y2, y1, it doesn't matter. The point is we'll evaluate this. You get 4 minus d over 0 minus c, which equates to d minus 4 over c. Right, if we were to evaluate this, because we'll get 4 minus d over negative c, and we'll just distribute that negative sign, giving us a value of d minus 4 over c. And so therefore, if we consider this an ordered pair and this an ordered pair both falling on the same line, we can then plug both of them into the slope formula, and if we simplify, we get d minus 4 over c. Okay. Question 9. In the simple equations above, k is a constant and x minus y are variables. For what value of k where the system of equations have no solution, right? So the way to get this to have no solution, right, is essentially to have an equation where the end result is an untrue statement, like 4 equals 7 has no solution, right? It's not a true statement. X equals to x plus 1 has no solution, right? Things like this. We want to get this into a form that has no solution. So how do we do that? Well, The key here is in manipulating this to produce something that, well, again, has no solution. So what we'll do is we'll set these equal to, we'll find the ratio that will separate these. So let's take a look at this. So we have kx minus 3y equals 4. We have 4x minus 5y equals 7, right? So if I multiply this by 3 over 5, right, what do I get? Multiply this by 3 over 5, well, I'll be able to turn this 5y into a 3y. So what I'll get is 12 over 5x minus 3y equals 21 over 5. That's the same equation as this one. So this is, we can call it equation 2. This is also equation 2. So now if I look at this original equation, right? Well, that's kx minus 3y equals 4. And so, well, what might k be to make this an untrue statement? Well, the key here is if I make k equal to 12 over 5, then I get the set of equations 12 over 5x minus 3y equals 21 over 5, and 12 over 5x minus 3y equals 4. And since these are the same, right, that means both these equations are essentially saying that 21 over 5 equals 4. And since that's not true, right, then 12 over 5 is that k value that gives us a value of no solutions, right? Because it makes both these equations the same, and therefore it produces an untrue statement. So A would be the correct answer in this case. All right, looking at question 10 here, we're given a parabola. Let's write that over here. With the equation x minus 11 squared is intersects the line y equals 25 at 2 points. Okay, so it's intersecting this line. They want us to find the length of AB, or the distance between those 2 points A and B, right? Okay, so again, we can just solve a system of equations here. We can take y, we know y is 25, right? We can plug in 25 for this y, since y equals y, right? So then we'll get 25 equals x minus 11 squared. This is just going to be a quadratic equation. We can take the square root of both sides. We'll get plus or minus 5. Don't forget that plus or minus is x minus 11. So we'll get 11 plus or minus 5. And therefore, our two solutions are 16 and also 6, right? Because we can subtract 5 there. So these are our values of x. X is equal to this, right? It's intersecting at these 2 points. So they want to know, okay, what is the length of AB? Well, the first thing we have to do is, okay, find out sort of we know y is 25, right? So we know y is 25, and then we know that these 2 points are our x values. So we know that these 2 points, therefore, are 6, 25 and 16, 25, right? Because these are both our x values, and the y value is constant. Right? So these are the 2 points we have to find the distance from. And if we were to graph these, right, they'd have the same height. The same height would be 25, but one is at 6 and one is at 16. So all we have to find is the distance between 6 and 16, since the height is the same, right? Which, of course, is 10. And so in this case, our correct answer would be 10, because that's just the distance between the x values.